Okay, I want to know, but what does that look like? Well, use that trigonometric identity. What's the e to the negative 2t is just a real factor which is going to reproduce itself. The question is, what does cosine t plus 2 sine t look like? What's its amplitude as a pure oscillation? It's the square root of 1 plus 2 squared. Remember, it depends on looking at that little triangle, which is 1, 2, this is a different scale than that. And here is the square root of 5, right? And here is phi, the phase lag. So it's equal to the square root of 5. So it's square root of 5 times e to the negative 2t. And the stuff inside is the cosine of, the frequency is 1. Circular frequency is 1, so it's t minus phi, where phi is this angle. How big is that? 1 and 2. Well, if this were the square root of 3, which is a little less than 2, it would be 60 degrees, so this must be 70 degrees. So phi is 70 degrees, plus or minus 10, 5, let's say. So it looks like a slightly delayed cosine curve, but the amplitude is falling. Looks something like, so it has to start. So if I draw here is 1, here is, let's say, the square root of 5 up about here. Then the square root of 5 times e to the negative 2t looks maybe something like this. So that's square root of 5 e to the negative 2t. How about this is cosine t, but shoved over by not quite pi over 2. It starts at 1 and with slope 0. So the solution starts like this. It has to be guided in its amplitude by this function out there. And in between it's the cosine curve, but it's moved over. So if this is pi over 2, the first time it crosses is 72 degrees to the right of that. So if this is pi over 2, it's pi over 2 plus 70 degrees, where it crosses. So it must be doing something like this. And now on the other side, it's got to stay within the same amplitude. So it must be doing something like this.